Imagine a small quadcopter drifting toward a radar site at night. No explosion, no warning. Just a shape moving slowly through darkness. On a modern battlefield, some of the most serious threats are easy to miss. Not because they are advanced, but because they are small, cheap, and everywhere. A small drone does not need heavy explosives or complex guidance to create problems. It only needs to be present, near a radar site, above a fuel depot, or close to a military installation that was never designed to deal with objects this small. Over time, militaries have learned a difficult lesson. Building drones is easy. Defending against them is not. This imbalance has forced a quiet shift in how modern defense systems are designed, away from dramatic interceptors, and toward layered defenses focused on detection, disruption, and control. One example of this shift can be seen in how counter-drone systems are now being used to protect fixed installations, not by destroying drones, but by stopping them with as little secondary risk as possible. This challenge has forced militaries to rethink what air defense actually means. For decades, defending airspace meant preparing for fast aircraft and large missiles. Systems were built for speed, altitude, and power. Small drones fall outside that logic. They fly low, they move slowly, and they often appear without warning. Using traditional weapons against them can work, but it quickly exposes a deeper problem: cost, scale, and risk near friendly infrastructure. Because of this, many defense planners are no longer asking how to destroy drones more efficiently. They are asking a different question. How do you manage a constant stream of small aerial threats without creating new problems in the process? The answer, in many cases, has not been a single new weapon, but a layered system built around detection, disruption, and controlled interception. One practical example of this approach can be seen in how some counter-drone systems are now designed to stop drones physically, rather than relying on explosions or heavy interceptors. This design choice is less about power and more about control. Once defense planners accept that drones are a management problem, rather than a one-time threat, the design priorities begin to change. The question is no longer how to eliminate every drone, but how to reduce risk without escalating it. That shift explains why some counter-drone systems are designed to intercept rather than destroy. Not because destruction is impossible, but because it is often unnecessary. In environments close to friendly infrastructure, even a successful interception can create secondary problems: debris, damage, and uncertainty about where a drone might fall. As a result, some systems focus on physically denying a drone the ability to fly. Instead of explosions, they rely on control and capture. At a conceptual level, this involves 3 steps. First, detecting a small aerial object that blends into background noise. Second, tracking it precisely enough to predict its movement. And third, intercepting it in a way that minimizes secondary effects. In practice, this is often done using a combination of short-range sensors and an interceptor drone. The interceptor does not need to be fast or heavily armed. It only needs to arrive at the right place at the right time. By deploying a physical capture mechanism, such as a net, the system removes lift or control from the target. Once that happens, the drone is no longer an active threat. This approach trades raw stopping power for predictability. It does not solve every problem, but it simplifies one part of a much larger defensive puzzle. However, interception systems have clear limitations, and those limitations matter. Detection is not guaranteed. Small drones fly low, move slowly, and often blend into background noise. Buildings, trees, and terrain interfere with sensors in ways that are difficult to predict. Even when a drone is detected, tracking it consistently is harder than it appears. Short-range sensors trade coverage for precision. Long-range sensors trade precision for delay. Interception also assumes timing works in your favor. A few seconds of delay can turn a controlled capture into a missed opportunity. There is also the problem of scale. Most interception systems are designed to deal with one or a few targets at a time. They are not built for saturation. As the number of incoming drones increases, decisions must be made about which targets matter most. Those decisions are not technical. They are human. Operators must balance uncertainty, incomplete information, and time pressure. A system that works well in isolation may struggle when attention is divided. This is why interception is rarely a complete solution. It is one layer among many, effective in specific conditions, and fragile outside of them. Because of these limitations, modern defense systems rarely rely on a single solution. Instead, they are built as layers. Detection feeds into disruption. Disruption buys time for interception. Interception reduces risk, but does not remove it entirely. Each layer compensates for the weaknesses of the others, but each layer also introduces new points of failure. A sensor can miss a target. A jammer can interfere with friendly systems. An interceptor can arrive too late. Layered defense does not eliminate uncertainty. It reorganizes it. The goal is not perfect protection. The goal is to manage probability, delay outcomes, and reduce consequences. This is why no single system is ever enough. Not because technology is inadequate, but because environments change faster than systems can be optimized. As threats become cheaper and more numerous, defense becomes less about stopping everything, and more about deciding what must be stopped and what can be absorbed. In practice, this reflects a broader shift in modern technology. Systems are no longer designed to be flawless. They are designed to fail slowly, visibly, and in manageable ways.